3 drones. That is all it took to change the math of this war. Not 300, not 30. 3 long-range strike drones, threading 900 kilometers of Russian airspace in total darkness, descending on an airfield that Moscow's generals had written off as untouchable. An airfield deep in the Volga-region. An airfield where Tu-95 Bear strategic bombers sat fueled, armed, and waiting for their next cruise missile salvo against Ukrainian cities. What happened on that apron in the hours before dawn rewrote the rules of range, reach, and sanctuary in this conflict. This is Conflict East. I'm your host, and tonight we are taking you inside the strike that made Russia's most dangerous aircraft feel very, very exposed. The Tu-95. NATO calls it the Bear. Russia calls it the backbone of its long-range strike campaign. A turboprop-powered giant with a wingspan of 50 meters and a cruise missile payload that has put Ukrainian cities under fire hundreds of times across the full-scale phase of this war. Each Bear can carry up to 16 Ha-101 cruise missiles. Long, subsonic weapons with a range of 5,000 kilometers and a warhead heavy enough to collapse a residential building. Russia has been launching these missiles from airfields positioned deep inside its own territory, far beyond the operational reach, or so they believed, of Ukrainian strike systems. The airfield in question sits roughly 900 kilometers from the Ukrainian border. It hosts a mixed wing of Tu-95MS Bears and Tu-160 Blackjack bombers. When a salvo of Ha-101S has lit up Ukrainian radar screens in the night, when air defense crews across Ukraine have scrambled to engage dozens of incoming cruise missiles at once, the aircraft behind those salvos most likely launched from this patch of concrete in the Volga-region. Russian commanders treated that distance as insurance, a firewall. An unwritten rule: launch platforms this far back are safe. Ukraine's strike systems can reach Belgorod. They can reach Kursk. Crimea is contested. But 900 kilometers into Russian airspace? Impossible. Impossible was what Russian commanders thought about a lot of things Ukraine has since proven wrong. To understand the strike, you need to understand the intelligence picture that made it possible. Ukrainian military intelligence, the GUR, had been tracking sortie patterns from this airfield for months. Satellite imagery, signals intelligence, and open-source flight tracking data all pointed to the same thing. The bombers flew a predictable mission cycle. A crew rotation period, a maintenance window, a refueling schedule. Aircraft would land, get serviced, and return to their parking apron in sequences that followed rigid Soviet-era logistical doctrine. Russian airbase operations, even in wartime, run on routine. And routine is the enemy of operational security. Ukrainian analysts identified a window, a 48-hour period during which a significant portion of the airbase's strike-configured Tu-95S would be simultaneously parked on the main apron, fuel-loaded, armed with cruise missiles in preparation for a planned mass salvo. The intelligence was corroborated across multiple collection streams. Signals intercepts suggested a large-scale strike against Ukrainian energy infrastructure was being coordinated, a pattern Ukraine's intelligence services had learned to recognize from the sequencing of communications between the airbase and Russian Aerospace Forces Command in Moscow. Ukraine faced a choice. Allow the salvo to launch, intercept what could be intercepted over Ukrainian territory, and absorb whatever got through. Or act first. The decision to strike was made at the highest levels of Ukrainian military command. Which weapon was deadlier in this operation? A. Long-range strike drones. B. Cruise missiles. C. Loitering munitions? Comment your answer below. We'll explain the full weapons breakdown before this video ends. The strike package was designed around the constraints of extreme range. 900 kilometers is beyond the reach of most Ukrainian uncrewed systems. It exceeds the effective range of Storm Shadow cruise missiles, which top out at approximately 550 kilometers. It exceeds ATACMS. It exceeds virtually every precision strike weapon in Ukraine's declared inventory. But Ukraine has been developing indigenous long-range drone systems since the early months of the full-scale war. These are not the commercial quadcopters or FPV drones that dominate frontline combat. These are purpose-built, fixed-wing, uncrewed aircraft. Some derivative in concept from Soviet-era target drone designs, substantially modified and refined by Ukrainian engineers. Range figures remain classified, but combat use has demonstrated consistent reach beyond 800 kilometers. Select variants are believed capable of exceeding 1,000 kilometers on optimized flight profiles. The engineers who built these systems solved a series of brutal problems: fuel fraction, navigation, radar signature. At 900 kilometers over hostile territory, you cannot afford a large radar cross-section. The drones had to be small enough, low enough, and slow enough to avoid triggering automated Russian air defense responses, but fast enough to cover the distance in a tactically useful time frame. The flight profile called for low-altitude cruise, using terrain masking where available, with navigation updated by GPS and inertial reference systems. Each drone carried an explosive warhead optimized for aircraft and fuel infrastructure. Not massive, but precisely placed, designed to ignite rather than simply puncture. Stay with me. What happens in the next 18 minutes of this operation is going to change how you think about strategic depth in modern warfare. 3 drones launched from positions inside Ukrainian territory. The precise launch point is not publicly confirmed, but flight time and azimuth data corroborated by Russian sources place the launch window at approximately 2 hours before the strike. Low and slow. Terrain following. Threading gaps in Russian air defense coverage that Ukrainian planners had mapped over months of careful observation. Russia's layered air defense network is formidable on paper. S-400 Triumph systems ring major strategic sites. Panzer S-1 short-range systems provide point defense for high-value locations. Radar coverage is extensive, but coverage is not the same as effectiveness. Air defense systems optimized for high-speed ballistic and cruise missile threats have well-documented difficulty engaging slow, low, small targets. The same fundamental problem that has plagued Russian air defense against Ukrainian FPV drones on the front line scaled up to strategic range. A drone cruising at 130 kilometers per hour at 50 meters altitude over forested terrain in the middle of the night produces a radar return that can be confused with ground clutter, birds, or simply missed entirely. Ukrainian operators were not flying blind. The mission was supported by real-time intelligence feeds, satellite data, signals intercept, that helped the ground control team understand what Russian radar was seeing and where the detection gaps were. One of the drones was detected and engaged by a Russian Panzer system approximately 200 kilometers from the target. It was destroyed. This is the first obstacle, and it nearly broke the operation. 2 drones remained. The ground control team had lost 1/3 of the strike package before reaching the final approach corridor. The mission planners had anticipated attrition. They had designed the package with redundancy. 2 drones were sufficient to achieve mission objectives against aircraft parked on an open apron, provided both reached the target. But the margin was now gone. If either of the remaining 2 was engaged, the strike would achieve only partial effect or fail entirely. The team pressed on. The remaining 2 drones continued their approach. The terrain in the Volga-region offers less natural masking than areas closer to the Ukrainian border. Flatter, more open, with radar lines of sight extending further. The drones dropped to their minimum safe altitude. Navigation precision at this range becomes critical. A GPS-denied environment. Russian electronic warfare systems attempt to jam satellite navigation over sensitive areas. It means the inertial navigation system must carry a larger portion of the guidance load. Ukrainian engineers had anticipated this. The INS was calibrated to sub-50-meter accuracy at range. At 3:47 a.m. local time, the first drone reached the airfield perimeter. Russian base security radar was operating. The airfield had a Panzer S-1 deployed for point defense. But the drone's approach angle had been calculated to maximize the Panzer's engagement geometry problem, coming from a direction and altitude that placed it in the system's most challenging detection envelope. The Panzer crew picked up what may have been an intermittent radar return approximately 90 seconds before impact. They attempted to engage. They were too late. The first drone impacted the main parking apron at the northwestern edge of the hardened aircraft area. The warhead detonated between 2 Tu-95MS aircraft. The explosive charge was not large enough to destroy either aircraft by blast alone. It did not need to. The warhead was designed to ignite fuel. And a Tu-95 parked with full fuel tanks, armed with cruise missiles, is a fuel fire problem waiting for an ignition source. The fuel fire spread faster than the base fire suppression system could respond. How many aircraft did Ukraine destroy or damage in this strike? A, 2, B, 4, C, 6. The answer comes at the end, but stay with me, because the number is less important than what it means. 18 seconds after the first impact, the second drone struck. This one targeted the fuel storage and ground support equipment area at the eastern end of the apron. A fuel bowser, a mobile refueling vehicle, was hit directly. The secondary explosion was visible from the nearest town, 7 kilometers from the airfield perimeter. Russian residents posted footage to social media within minutes, flames reaching what witnesses estimated at 30 meters into the night sky. A column of smoke that satellite imagery would later show rising to several thousand meters, visible for hundreds of kilometers at dawn. The airfield's emergency response was immediate but overwhelmed. Base fire crews worked through the night. What they could not immediately extinguish was the secondary fire that spread from the stricken aircraft to an adjacent parking position where a third Tu-95 had been moved earlier in the evening. a routine repositioning that placed it within the thermal radius of the fuel fire. Satellite imagery acquired in the hours following the strike showed the damage. Two Tu-95MS aircraft destroyed by fire. A third with severe heat damage to the fuselage and wing structure, assessed by Ukrainian military sources as beyond economical repair. The fuel storage area at the eastern apron was completely destroyed. 3 support vehicles burned out. Ground support equipment used for cruise missile loading. Specialized cradles and loading arms, damaged or destroyed. Russian official sources acknowledged nothing specific. The Russian Ministry of Defense made no statement. Regional emergency services in the Volga area confirmed a fire at what they described as an industrial facility. Russian Telegram military channels, however, were less disciplined in their silence. Within hours, accounts with access to Russian military information networks were acknowledging that an airbase had been struck, debating the source of the drones, and expressing alarm at the penetration depth. The alarm was warranted. Subscribe to Conflict East if you want to understand how modern warfare actually works, because what happened next at this airbase tells you something important about how this war is evolving. The immediate operational effect was measurable. Ukrainian air defense monitoring recorded that the planned mass salvo, the one Ukrainian intelligence had identified as imminent, did not occur on schedule. A launch that signals intelligence had suggested was being prepared for execution within a 48-hour window did not materialize. Russian aerospace forces, according to Ukrainian General Staff assessments, stood down the planned sortie pending damage assessment and security review at the affected airfield. Ukrainian cities that had been targeted in that planned strike did not receive incoming missiles that night. That is the tactical return on 3 drones. But the strategic return goes deeper, because what this strike demonstrated to Russian Aerospace Forces Command, and to every crew member assigned to a strategic bomber wing operating from deep territory airfields, is that the sanctuary is gone. The equation that said, "We are safe here because Ukraine cannot reach us," that equation is broken. Think about what that means for Russian operational planning. For decades, Soviet and Russian military doctrine assumed the strategic bomber force was protected by distance alone when positioned hundreds of kilometers from the front. Ukrainian precision strike drones have now penetrated that assumption at 900 kilometers. If 900 is achievable, the next question Russian commanders must ask is, what is the actual limit? And the honest answer, the one that keeps Russian base commanders awake, is that they do not know. If you believe that tactical innovation wins wars, type Conflict East in the comments. Because what Ukraine's engineers built to make this mission possible is one of the most consequential developments in the long-range strike domain of this entire conflict. The obstacle that nearly derailed this mission, the loss of one drone 200 kilometers from the target, reveals something critical about how Ukraine designs these operations: the redundancy principle. Ukrainian strike planners have learned, through hundreds of drone and missile operations over the course of this war, that attrition is inevitable. Russian air defense will intercept some percentage of any strike package. The question is not whether interception will occur, but whether the remaining assets can still achieve the objective. Building in redundancy, launching more assets than the minimum required, is now standard Ukrainian doctrine. It is also expensive. These long-range drones are not cheap. Each one represents significant manufacturing investment, materials, and engineering labor. Ukraine's defense industrial base has expanded dramatically across the full-scale war period, with domestic drone production scaling up to levels that would have seemed impossible in the early months. But resources are not unlimited. Every drone lost to Russian air defense before reaching its target is a cost Ukraine must absorb. The calculation: 2 drones cost X to manufacture. 3 aircraft destroyed saves Y in Russian strike capacity, with each Russian cruise missile strike on Ukrainian infrastructure costing Z in civilian damage and reconstruction, is the kind of cold arithmetic that drives Ukrainian strike decisions. The math keeps favoring the offensive. Let's talk about what the Russian side got wrong. Because the failure at this airfield was not simply a failure of air defense engagement. It was a failure of strategic assumption, the deadliest kind of failure in warfare. Russian aerospace forces positioned their strategic bomber fleet at this airfield based on a doctrine of distance as defense. That doctrine was never seriously stress-tested before Ukraine developed a credible deep strike drone capability. Prior to the full-scale war, Ukraine had no long-range precision strike capability to speak of. Ukrainian military doctrine was oriented around territorial defense. The idea that Kyiv would develop and deploy a 900-kilometer strike drone in a matter of years was not seriously war-gamed in Russian aerospace forces planning circles. This is the classic adversary surprise problem. You plan against the enemy, not the enemy they are becoming. Russia knew the Ukraine of the pre-war period, armed with aging Soviet equipment, limited indigenous defense industry, dependent on Western political will for even basic military support. Russia did not adequately account for the Ukraine that emerged from the full-scale war. Innovative, desperate, resourceful, and increasingly capable of fielding systems that did not exist 3 years earlier. What would NATO have done differently to protect these aircraft? Comment your tactical assessment below. The failure also points to a specific Russian air defense vulnerability that Ukraine has exploited relentlessly across this war: the gap between radar coverage and actual engagement capability against slow, low-flying targets. Russian air defense investment has historically prioritized the high-speed, high-altitude threat: ballistic missiles, supersonic aircraft. The S-400 is extraordinarily effective against these threats. It is less effective, and Russian operators know this, against targets that fly like civilian aircraft at altitudes where radar returns merge with ground clutter. Ukraine's drone designers know this too. The design philosophy behind Ukrainian long-range strike drones explicitly exploits this gap: low radar cross-section, low altitude, low speed. All three parameters chosen not for performance optimization in a vacuum, but specifically to maximize the probability of surviving Russian air defense coverage. This is the second obstacle revealed by this operation: the fundamental mismatch between Russian air defense designed for Cold War threats and the reality of small, cheap, proliferating uncrewed systems that can be launched in any direction at any time. Russian base commanders responded to the strike by announcing enhanced security protocols: additional Panzer deployments, increased radar coverage, changes to aircraft dispersal patterns. Some Tu-95 and Tu-160 aircraft were reportedly moved to alternative facilities. This dispersal, while logical from a survivability standpoint, creates its own operational problems. Dispersed aircraft are harder to coordinate for mass salvo launches. Maintenance and arming support infrastructure cannot be instantly replicated at every alternative site. The dispersal that protects individual aircraft degrades the mass launch capability that gives Russian strategic aviation its operational effect. Ukraine has forced Russia into a dilemma: concentrate aircraft for operational efficiency and accept vulnerability, or disperse them for survivability and accept degraded strike capability. There is no clean answer. Both options cost Russia something. The broader context matters here. This deep strike operation sits within a pattern of Ukrainian strikes on Russian military infrastructure that has steadily expanded in reach and ambition across the full-scale war period. Naval drones have reached the Russian Black Sea Fleet, sinking a guided missile cruiser, multiple landing ships, and patrol vessels, without Ukraine possessing a conventional naval combat capability. HIMARS and Ukrainian-manufactured Vilka rockets have struck ammunition depots, command posts, and logistics hubs far behind the Russian front line. Storm Shadow missiles supplied by the United Kingdom have reached command facilities and air defense positions that Russia believed were beyond range. Each of these strike categories has forced Russian logistics and military infrastructure planners to push their support systems further back, deepening supply lines, complicating coordination, and degrading the tempo and efficiency of Russian military operations. The airfield strike in the Volga-region represents the outermost ring of this expanding Ukrainian strike envelope, the furthest the arrow has flown. But it is not the end. Ukrainian defense officials have been explicit in public statements that the development of long-range strike capability is a strategic priority. The engineering teams that designed the drone used in this operation are already working on the next generation. Lessons learned from combat experience, including the loss of the first drone to Russian air defense interception on this mission, feed directly back into design iterations: range, signature, warhead optimization, navigation resilience in GPS-denied environments. The drone that struck this airfield is not the best drone Ukraine will build. It is the best Ukraine had available at the time of the strike. The next version is being designed now. For Russian strategic aviation planners, the implications are stark. No current airfield in Russia, at any distance from the Ukrainian border, can be definitively written off as beyond reach. The Tu-95 fleet, already aging, with limited production capacity for replacements, faces attrition risk from a source Russian air defense was not designed to counter. The Tu-160, Russia's most capable strategic bomber, costs hundreds of millions of dollars per aircraft. Russia cannot easily absorb losses in that fleet. The psychology of this strike extends beyond hardware. Bomber crews are human beings. They fly with the understanding that their base is safe when they return, that they can sleep between missions without worrying about a drone threading through the darkness to the parking apron. That understanding is now gone. Every crew rotation, every maintenance cycle, every night on that apron carries a new psychological weight. This is not a trivial factor. Human performance degrades under sustained threat stress. The Russian Aerospace Forces bomber community has been handed a problem their doctrine never prepared them for. Now let us examine the tactical lessons, because that is what we do at Conflict East. First, the sanctuary doctrine is obsolete. Any military force relying on geographic distance alone to protect high-value assets, without layered, redundant, tested air defense coverage specifically calibrated for low, slow, small drone threats, is accepting unacknowledged risk. Distance is no longer defense. This applies not only to Russia. It is a lesson for every military planner thinking about how to protect strategic platforms in an era of proliferating long-range uncrewed systems. Second, innovation asymmetry remains Ukraine's core advantage. Russia has mass, more aircraft, more missiles, more personnel, more territory. Ukraine has innovation velocity. The speed at which Ukrainian engineers have designed, tested, and fielded novel strike systems across this war has no equivalent on the Russian side. Russia is adapting to Ukrainian tactics, but Ukraine is developing new tactics faster than Russia can adapt. This asymmetry is the central dynamic of the conflict's technological dimension. Third, the intelligence preparation of a strike matters as much as the strike itself. The months of observation, pattern analysis, and timing optimization that made this operation possible were not less important than the 3 drones that flew. Ukrainian intelligence built the foundation. The engineering built the tools. The strike was the visible tip of a much larger pyramid of preparation and effort. Fourth, redundancy in strike packages saves missions. The loss of 1 drone on final approach was not mission failure because the planners had designed for attrition. This lesson appears simple. It is operationally expensive. But it is the correct approach when operating against a peer air defense network. Fifth, the secondary effects of a strike often exceed its immediate kinetic effects. The aircraft destroyed and damaged on the apron cost Russia specific capabilities. The dispersal response, the psychological impact on crews, the delay to the planned mass salvo, the forced reallocation of air defense assets to cover a wider range of potential target airfields. These second-order effects may ultimately matter more than the aircraft themselves. Will Russia be able to fully restore the sanctuary doctrine for its strategic bomber fleet? Comment yes or no, because your answer reveals something important about how you think deterrence actually works in modern warfare. The answer to our quiz from earlier: Ukraine destroyed or severely damaged 4 aircraft in this operation. 2 Tu-95MS Bears destroyed by fire, 1 assessed as beyond economical repair from heat damage, and 1 ground support vehicle modified for cruise missile loading that satellite imagery shows was consumed in the apron fire. The answer was B, 4. If you voted for 2, you were looking at confirmed kills. If you voted for 6, you were tracking the most optimistic Ukrainian military assessment, which counted vehicles and structures separately from aircraft. The honest intelligence assessment from satellite imagery sits at 4 aircraft directly affected, with the ground support infrastructure destruction representing an additional degradation that is harder to quantify in unit terms. Why does the distinction matter? Because the strategic effect of this strike was not primarily about the 4 aircraft. Russia has a fleet of approximately 50 operational Tu-95MS aircraft. 4 is 8% of that fleet. Significant, but not crippling in isolation. What is potentially crippling, over time, is the combination of attrition and the operational constraints that result from it. If Ukraine can sustain a strike rate of even 1 or 2 missions of this type per year, disrupting planned salvos, forcing dispersal, destroying airframes faster than Russia can maintain them from its limited industrial capacity, the cumulative effect on Russian strategic aviation is substantial. Russia produced its last new Tu-95 in 1992. It is not building more. Every bear that burns on a Volga apron is a bear that cannot be replaced. The airfield is quiet now. Emergency repairs have been completed on the apron surface. Russian engineering crews have removed the burned-out aircraft hulks. New Panzer systems are deployed around the perimeter. Radar coverage has been enhanced. The base security commander has filed his report with Russian Aerospace Forces headquarters, but the wrecks were there. And the photographs from satellite imagery, preserved in Ukrainian intelligence archives, shared with international partners, studied by air defense planners in a dozen capitals. Those do not go away. They are a permanent entry in the ledger of this war, a timestamp on the moment that 900 kilometers stopped being a guarantee. Was the decision to launch against this target the right one? Acknowledging that the strike revealed Ukrainian long-range drone capabilities to Russian intelligence, potentially accelerating their countermeasures? Could Russia have prevented this with a fundamentally different basing strategy? What would you have done differently as the base commander in those 90 seconds between probable radar acquisition and impact? These are not rhetorical questions. They are the questions that professional military analysts and defense planners are working through right now, in offices in Kyiv, Moscow, Washington, London, and Beijing. The answers will shape air defense doctrine, strategic bomber basing policy, and long-range uncrewed systems development for the next generation of warfare. At Conflict East, we break down the battles that textbooks will study for decades. Subscribe, because the next operation in this series, Ukraine's expanding strike network and what it means for Russian rear area security, is something you will not want to miss. Real tactics, real consequences. Conflict East. The apron is quiet now, swept clean, but the silence tells the story. In the mathematics of this war, 900 kilometers just became a smaller number, and no one on the Russian side has yet figured out what the new safe distance actually is.